చేయండి పైన ముందు అయితే రైట్ ఇప్పుడు మీరు పవర్ పాయింట్ ఓపెన్ చేసుకొని చెప్పుకోవచ్చు.
ఏది నా పవర్ పాయింట్
కింద
ఇదా
అదే ఆల్రెడీ ఓపెన్ చేస్తారు.
ఇది కొద్దిగా పెద్దగా చేయాలి కదా.
ఇక్కడ కింద కప్ షేప్ ఉంది చూడండి, జూమ్ పక్కన అది
ఇదా
అంతే. అయిపోయిన తర్వాత స్టాప్ కొట్టాలి.
ఓకే. Good morning everyone. Today I am going to talk about lymphatic system. Okay. So lymphatic system, this is your lymphatic system. Here I want you to concentrate, there are lymph nodes in between. So this lymphatic system transfers through the lymph nodes. Okay. But this lymphatic system, actually I would call it an unsung heroes because they do so much of work but they are not getting their recognition. Okay. Okay, now coming to the lymphatic system. So what does this lymphatic system do? Lymphatic system represents an accessory route through which fluid can flow from the interstitial spaces into the blood. So fluid, whatever is there in the interstitial spaces, will go into the blood via this system, lymphatic system. So as you all know, this is a capillary bed. As you all know, capillaries are your exchange vessels where it will exchange gases and nutrition. Okay. So this is the arteriolar end of the capillaries. These are the venous end of capillaries. So arteriolar end of the capillaries will have filtration. So they are filtering the fluid, and venous end of the capillaries will pick up that fluid. So supposing in a day 20 liters of fluid is filtered in a day. 20 liters of fluid is filtered at the arteriolar end and 17 liters is picked up by the venous end. The 3 liters is remaining in the interstitial spaces. The 3 liters of fluid is going via the lymphatic channels into your heart. So why should this system why is this system so important? Because it takes away, so though the capillaries are they are impermeable to plasma proteins, but there is definitely some leakage of the plasma proteins from the capillaries into the interstitial fluid. So that protein, whatever protein is leaked out from the capillaries, that little bit of protein, particularly albumin, because albumin size is small, though the molecular weight of the albumin is more, but the size of the albumin molecules are small, they leak out from the arteriolar end. That albumin is picked up by your lymphatic capillaries. If that albumin was not picked up by the lymphatic capillaries and if it is gone out of our body, we would have all died in 24 hours. So this part of picking up the albumin is done by your lymphatic vessels. Not that all the plasma proteins will leak out, because the size of this albumin is smaller, it is coming out. Not all of the albumin, but little bit of albumin is coming out. So that protein, whichever is leaked out into the spaces, is taken back by the lymphatic channels into your heart. So nothing is getting wasted. So apart from protein, some other large particulate matters also it will collect. So lymphatics can carry protein. This is very important. Whenever they ask you the functions of lymphatics, first thing you should say is lymphatics can carry protein and large particulate matter. So large particulate matter means something like your hormones, lipids, they can be also carried by this lymphatic system, which could not have been removed by absorption directly into the blood capillaries. Some large particles which cannot be absorbed at the venous end of the capillaries because the size of the pores size between the endothelial cell is very small. So this could not have entered the venous end of the capillaries. So they have to go only through your lymphatic system. So this is the importance of lymphatics. So what all, from where all, so almost all the tissues of the body, all the tissues of our body have lymphatic channels. except superficial portions of skin, CNS, endomysium of muscles and bones. So everywhere these lymphatic channels are existing in our body. All the tissues have got this except superficial portions of skin, CNS, endomysium of muscles and bone. So even these have got minute interstitial channels called pre-lymphatics. Even the CNS, endomysium also have got small minute channels called pre-lymphatics, where the interstitial fluid can flow and it is also going to your lymphatic vessels. For example, in CNS, the fluid will get into the CSF and from there into the blood. So, now lymphatic channels, lymph from lower part of the body, left side of head, left arm, left thorax enters the thoracic duct. And this thoracic duct opens into the left subclavian vein. So, this thoracic duct is a bigger duct. So, it's a bigger duct. So it is taking lymph from almost most of the tissues of our body. So, lymph from right side of neck, head, right arm, right thorax enters the right lymphatic duct. Comparatively, right lymphatic duct is much smaller than your thoracic duct, which opens into the right subclavian vein. So, it will open into the right subclavian vein. So, the lymph that returns to the circulation by way of lymphatics is 1/10. So, that's what I told you. So, about 20 liters of blood is getting filtered at the capillary, arterial end of the capillaries. Only 17 liters is getting picked up at the venous end of the capillaries. So, that 3 liters is there. So, it is about 1/10. So, 2 to 3 liters that fluid is flowing via your lymphatic channels. So, this is the diagram. The pink one represents the left side. So, the green one represents the right lymphatic duct. So, whatever areas I told you, head, upper part of the chest, upper arm is all carried by your right lymphatic duct. So, most part of our body is by a thoracic duct. So, thoracic duct is a bigger duct than the lymphatic duct. So, okay. So, how does it go? So, these are the capillary bed. Filtration is occurring at the arteriolar end. So, whatever fluid is remaining in this interstitial spaces, which is not absorbed at the venous end of the capillaries, that fluid is getting picked up by the lymphatic capillaries. These lymphatic capillaries join together to form the lymphatic vessels. Lymphatic capillaries join together to form the lymphatic vessels, and they go through the lymph nodes. Then these lymphatic vessels join together to form the lymphatic trunk. Then this lymphatic trunk drains into the lymphatic duct, and this lymphatic duct will pour your fluid into your heart. So, lymphatic capillaries will become lymphatic vessels. Lymphatic vessels will become lymphatic trunk and lymphatic duct. So, this will enter your heart. So, right and left side, let us see. So, right lymphatic duct empties at the junction of right internal jugular vein and right subclavian vein. Right lymphatic duct. Left side I said is a thoracic duct. Thoracic duct empties into junction of left internal jugular and left subclavian vein. And both this right and left duct join together to form the brachiocephalic vein, and this brachiocephalic vein into the superior vena cava, and superior vena cava into the right atrium. That is how the lymph is getting into your right atrium, into the heart. So, right side into right subclavian vein, left side thoracic duct into left subclavian vein, and everything is going into your superior vena cava, and it is entering into your right atrium of the heart. Now, structure of the lymphatic vessel. So, I said venous end of the capillaries, some particles are not getting picked up by the venous end of the capillaries, but they are getting picked up by the lymphatic vessels. Why? Because lymphatic vessels are made up of single layer of endothelial cells, and behind the endothelial cells there is no basement membrane. And in between the endothelial cells, there is no tight intercellular junctions. So the edge of one endothelial cell overlap the other endothelial cell in such a way they form a minute valve. They form a valve, and that the fluid will enter the interior of the lymphatics. Okay, because blood capillaries, the pores between the endothelial cell is small, whereas here the gaps between the endothelial cell is big. That is why bigger particles can enter into the lymphatics. So once the tissue cells are filled up with the fluid, excess fluid. So what will it do? The anchoring filaments, here in the diagram you can see anchoring filaments are pulled up and the fluid enters into the interior of the vessel. Whenever the pressure in the interstitial fluid is more, the fluid, when the interstitial fluid pressure is more than your lymphatic vessel pressure, the fluid enters inside. And once the pressure in the lymphatic vessel increases, then that of your interstitial fluid pressure, then this endothelial cells close. So once it is closed, the fluid can't come out of the lymphatic capillaries into the interstitial spaces. Once the fluid is inside, it can't come out. Okay, now these have also valves in it. Okay, we'll come to it later. So here what I want to tell you is, when the pressure is more in the interstitial fluid than that of the lymphatic vessel, fluid is pushed inside the vessel. So when the pressure in the lymphatic vessel exceeds that of your interstitial pressure, the endothelial cells close. Once they close, the fluid cannot come out of it. So these are the blind ends. Okay. So it is closed at one side, okay, but the fluid is entering through the endothelial cells. So what is the composition of lymph? Lymph is nothing but the interstitial fluid. So interstitial fluid at the terminal lymphatics is just, the composition is just the same as that of your interstitial fluid. So once the interstitial fluid enters the lymphatic vessels, then only we will call it as lymph. Outside is only the interstitial fluid, it is the extracellular fluid only. Once the interstitial fluid enters into the lymphatic channels, then only we will call it lymph. Okay, so lymph is nothing but the modified tissue fluid. It is the interstitial fluid only. It is transparent. It is yellowish in color. It is slightly alkaline and it clots slowly. Colloidal osmotic pressure is less than that of plasma. So everything is more or less like plasma, but the colloidal pressure is less because in the capillaries proteins are more. That is why they maintain the colloidal osmotic pressure. Comparatively to the proteins outside are less. Proteins out in the interstitial fluid is less. That is why colloidal osmotic pressure is less than that of plasma. So what else does it have? It has proteins. It varies with different tissues. We'll come to it. Then it has got lipids. Then it has got carbohydrates. It has got coagulation factors. It has got cellular components and others. So coming to the protein part, protein concentration. Protein content varies with different tissues. Different tissues will have different protein content. So protein concentration of interstitial fluid is about 2 grams per deciliter. So interstitial fluid protein is about 2 grams per deciliter. But when it is collecting from the liver area, the protein content increases because liver has got discontinuous sinusoids. So lot of protein will come into the interstitial fluid. So the liver has got 6 gram %. Intestine, heart, lung, thoracic duct is about 4 gram %. We are talking about proteins. So intestines will have fenestrated capillaries. That is why leakage of protein will be there that side also. So it has got about 4 gram %. Skin and skeletal muscle is 2 gram % because skeletal muscle has got tight capillaries without any junctions in between. So lot of protein is not lost there. So it is about 2 gram %. Leg is about 1 to 1.5 gram %, and choroid plexus and ciliary body is 0%. So protein concentration varies with the different tissues from where it is getting picked up. Lipids. So lymph will also have lipids. So lipids naturally are more in the intestinal region and less in thoracic duct, because lymphatics of intestinal region, what are they called? Lymphatics of intestinal region are called lacteals. They absorb and transport lipids. It gives milky color to lymph, because supposing we have eaten a double cheeseburger, it has got lot of fat in it. Fat molecules are more in it. So that will give white color to the lymph because of lipoprotein absorption from the GIT. So that is called, that white color is called chyle, CHYLE, chyle. So lipids are more in the intestinal region because absorption is occurring from the intestine. Transport and absorption of this lipids is occurring in the intestine. That is why intestinal region will have more lipids. Then carbohydrates. Carbohydrates are less than the plasma concentration. Coagulation factors. Coagulation factors are more in liver lymph, because compared to the peripheral lymph, the coagulation factors are more in the liver lymph, because coagulation factors are synthesized in the liver. That is why lymph clots on standing. So if you keep the lymph like that, because of these clotting factors, lymph clots on standing. Cellular components. Because cellular components, what component should be more? Lymph will have lymphocytes more. Contains large number of lymphocytes of all sizes. No granulocytes. It contains few RBCs and the platelets. So the lymph will have lipid, protein, lipid, carbohydrates, coagulation factors, cellular components, and it will have others like sodium, potassium, chloride, sulfate, calcium, phosphorus, and non-protein nitrogenous substances like urea, creatinine, etc. Because it is just like the composition is just like that of plasma, but protein content in the lymph is much lesser than that of the plasma. Now, so lymphatics. So these are the lymphatic capillaries. Here in diagram I can show you the lymphatic capillaries. They are becoming joining together and forming the lymphatic vessels. Lymphatic vessels are becoming the lymphatic trunks. Lymphatic trunks are becoming the lymphatic ducts. Collecting duct or lymphatic duct. Lymphatic trunks join together to form the lymphatic duct. And this right side and thoracic duct will empty into the superior vena cava and into the right atrium. So in this diagram we can also say lymph is flowing only towards the heart. Why? Just like veins, because the pressure in the veins is also less and pressure in the lymphatics is also less. So it is only, they can only flow towards the heart. So why lymph flows towards the heart? Lymph has got the contractile valves in lymphatics. I told you valves are there in the lymphatics which prevent the retrograde flow of lymph. So it has to go only towards the heart, just like your veins. And the muscle pump, skeletal muscle pump. So skeletal muscle pump, whenever skeletal contraction of the skeletal muscle will compress your lymphatics. So your lymphatics are going towards the heart. Peristalsis is there in the GIT. So again taking towards the heart. Rhythmic contractions of walls of large lymphatics. Large lymphatics are contractions are occurring in the large lymphatics, and also interstitial fluid pressure is 1.9 centimeter of water. Interstitial fluid pressure is that much, whereas the pressure in lymphatics has to be less. That is why the lymph is flowing from the interstitial fluid into the lymphatic vessel. So pressure in the interstitial spaces is about 1.9 centimeter, whereas pressure in the lymphatic system is 1.3 centimeters of water. That is why it is coming into your lymphatic system. So negative intrathoracic pressure during inspiration. During inspiration there is negative intrathoracic pressure. That means it sucks. Whenever it is negative, it sucks more of the lymph. That is why lymph is flowing towards the heart. What are the functions of lymph? So transports proteins, whatever proteins has been leaked out from the capillaries, almost entirely all the proteins are getting collected by the lymphatic vessels and taken back into circulation into your heart. So whatever leakage is there of the proteins from your capillaries, all that is collected by the lymphatic channels and it is returned back to the circulation. Second one, it transports absorbed long chain fatty acids and cholesterol from the intestine. Okay, they absorb long chain fatty acids and cholesterol from the intestine, and via lymphatics it is returned back into the blood because it's long in the form of chylomicrons. Because this chylomicrons can't be picked up at the venous end of the capillary, so it is done only via lymphatics. So it transports absorbed long chain fatty acids and cholesterol from the intestinal region, and it is collected back into lymphatics and emptied into the circulation. And third function, it transports RBC, WBC and bacteria to regional lymph nodes. It transports RBC, WBC and bacteria to the regional lymph nodes. And it transports antibodies. That's why lymphatic system has got immune function also. It transports antibodies, and it helps. Next function, it helps in the formation of maximally concentrated urine. It helps in the formation of maximally concentrated urine by maintaining the osmotic gradient between medullary interstitia and vasa recta. It maintains that osmotic gradient between the medullary interstitia and the vasa recta for the smooth operation of the counter current mechanism. That is how it helps in the formation of maximally concentrated urine. Next function, it transports large enzymes like histamine and lipase. Large enzymes, whatever are large, which cannot be picked up by the venous end, has to go through the lymphatics only. It transports large enzymes like histamine and lipase into the circulation. It supplies nutrition and oxygen to parts where blood cannot reach. So what examples I can give you? Cartilage and cornea. So it supplies nutrition and oxygen to parts where blood cannot reach. So examples could be cartilage and cornea. It enhances the efficiency of the immune system. Why? Because I told you this lymphatic vessels, in between it transfers through the lymph nodes. These lymph nodes are the efficient filters. They are the efficient filters, and these sinuses are lined by the phagocytes, which can engulf bacteria, your damaged RBCs, and also large particulate matter. So it enhances the efficiency of the immune system because through your lymph nodes. These are the functions of lymph. So functions of lymph, whenever they ask you functions, the first important function you should say it will transport protein. Okay. Next one. Rate of lymph flow. So I told you thoracic duct is a bigger duct because it is collecting lymph from larger parts of our body. So through the thoracic duct, about 100 ml per hour through other channels like your right lymphatic duct. Through other channels, it collects about 20 ml per hour. So total flow is about 120 ml per hour or 2 to 3 liters per day. 2 to 3 liters per day. Initially only I told you 20 liters is getting filtered in a day from the arterial end. Only 17 liters is picked up by the venous end. So the 2 to 3 liters is collected by the lymph. So total flow of lymph is about 2 to 3 liters per day. So what are the factors that determine the lymph flow? So why should what factors are essential to have that much of lymphatic flow? So there are two important things, interstitial fluid pressure, and the next is the activity of the lymphatic pump. Interstitial fluid pressure and the activity of the lymphatic pump. That is why that much of lymph is going into your right atrium. Okay, so interstitial fluid pressure. So what are the factors that influence the interstitial fluid pressure? Capillary pressure. So should the capillary pressure be more or less? So the capillary hydrostatic pressure in the capillaries should be more. increased capillary pressure. So more fluid enters the interstitial spaces. So when more fluid comes into the interstitial spaces, more fluid is taken via the lymphatic channels. So increased capillary pressure. So increased hydrostatic pressure, that is one. Second is plasma colloidal osmotic pressure. So this should be decreased plasma colloidal osmotic pressure. When the plasma colloidal osmotic pressure is less, then only the fluid will get filtered into the interstitial spaces. If the plasma colloidal pressure is more, it will absorb the fluid into the capillaries. So the decreased plasma colloidal osmotic pressure means lot of filtration is occurring into the interstitial spaces. So increased hydrostatic pressure, decreased plasma colloidal pressure, interstitial fluid colloidal osmotic pressure. This also should be, interstitial fluid also should be increased. Whenever there is protein in the interstitial fluid colloidal osmotic pressure increases. This will shift the balance for filtration. As the capillaries have got both the hydrostatic pressure and the oncotic pressure, interstitial fluid will also have both hydrostatic pressure and the oncotic pressure. The osmotic pressure by the proteins is called the oncotic pressure. Osmotic pressure exerted by the proteins is your oncotic pressure. So whichever side the protein is there, it will drag the fluid that side. So interstitial fluid will have some protein. So fluid is dragged into the interstitial spaces. So increased interstitial fluid colloidal osmotic pressure. So, and also the fourth one is the permeability of the capillaries. When permeability of the capillaries, I told you in shock also, hypoxia, severe anemia, or whenever there is increase in the temperature, or some toxins are getting accumulated in the capillaries. So there occurs vasodilatation. When there is vasodilatation, there will be permeability of the fluid, because whenever there is vasodilatation, the gaps between the endothelial cells increases. So fluid will come out of the capillaries. So permeability of the capillaries. So these are the four factors: increased capillary pressure, decreased plasma colloidal osmotic pressure, increased interstitial fluid colloidal osmotic pressure. So whenever the proteins are more in the interstitial fluid, more water is dragged into the interstitial fluid. All this put together will influence your interstitial fluid pressure, and whenever the pressure is more in the interstitial spaces, the rate of lymph flow also increases. So lymphatic pump also plays an important role. Second role is factors influencing the lymphatic pump. So what valves in the lymphatic channels? Lymphatic pump. So valves in the lymphatic channels, coming to this diagram. So whenever the lymphatic vessels are stretched with the fluid, there will be contraction of the smooth muscle on the walls of the lymphatics. When there is contraction, it will push the fluid forward. Contraction, the valve opens and the fluid is pushed forward, and then behind valves will get closed. Okay, and again when the next segment fills up with fluid, it contracts, and the same way again the fluid is pushed forward. So until it reaches the right atrium. So because of this valve, whenever smooth muscle valve will contract the segment and the fluid is pushed into the next segment. So again when that segment is filled up, again the smooth muscle wall acts there, and again it is pushed up until it empties into your right atrium. So this is the valve factors influencing the lymphatic pump, are the valves in the lymphatic channels. Next one is a contraction of the surrounding skeletal muscles, because whenever surrounding muscles get contracted, there will be compression on these lymphatic vessels and the lymph will move forward. Then movements of the parts of the body, whenever we are exercising also, lymph will flow. All this will contribute to a lymphatic pump. Pulsations of arteries, adjacent big arteries are there, they are pulsating. So that will put pressure on the lymphatics and lymph is flowing. Okay, and the other one is compression of tissues by objects outside the body. So whenever you are compressing some tissues either with your hand or with some other object, so that also will increases the lymphatic pump. So it depends, lymphatic flow depends upon the interstitial fluid pressure and your lymphatic pump. So these are the factors which will influence the lymphatic pump. So lymphatic pump is very active during exercise. It will increase the lymph flow, and during periods of rest, whenever we are lying down, during periods of rest, lymph flow is sluggish. So applied aspect. So whenever your lymphatic vessels are filled with the lymph, elephantiasis, you must have heard about elephantiasis. It is caused by obstruction of the lymphatic system, which results in the accumulation of fluid called lymph in the affected areas. Elephantiasis is caused because of the parasites. Whenever by the female mosquitoes, whenever they are infected by microfilaria, when those female mosquitoes bite the human beings, this microfilaria will become into the adult worm in the lymphatic vessels, and they block the lymphatic vessels. They block the lymphatic vessels and leading to elephantiasis. So this is the diagram, elephantiasis, because they are, it's like an elephant leg. That is why it's called elephantiasis. Blocking of the lymphatic vessels will lead to elephantiasis, filariasis. Okay. Hope you have understood the class. This is about the lymphatic system. Thank you.